Hi, my name is Marcos, and I'm here with my colleague Vicente to present our project, which has been based in the study of a fully supervised speaker diarization process. This project has a clear objective, explores the challenge of training a supervised learning-based system, leveraging from the integration of two other speech recognition system-based projects. These two projects provide two baseline models, the unbounded interleaved state recurrent neural network and VGG speaker recognition. Later, these two models will be discussed in more detail. As data input, it has been chosen the free open Mandarin corpus, which contains 855 speakers and 120 utterances of Chinese Mandarin. This dataset is 100 hours long, containing a 50-50 gender ratio. It was mono-recorded at 16 kilohertz with 16-bit depth and uncompressed coded with waveform format. Now we're going to discuss in more depth the first of these two models, the VGG speaker recognition. This model is entirely based on previous work in which the premise were to effectively condense the frame level available information into an utterance level speaker representation. For that purpose, the proposed of this idea was combining the convolutional neural network pooling but not content-dependent features with a dictionary-based net overlap layer. The convolutional neural network proposed was a thin residual network. Compared to the standard residual networks, this is a network which has been cut down the number of channels in each residual block, making it a thin residual network 34 layer. Additionally, during the embedding expression, it is used the short-term magnitude spectrum as input to the convolutional neural network architecture. Mean and variance normalization has been performed in order to in every frequency bin of the spectrum. Features produced by the trunk of this convolutional network architecture are then aggregated in time to produce a single fixed length representation of each audio input. This is the duty of the net overlap layer, who takes the dense descriptors as inputs and performs a soft assignment weight of the input vector, computing the residual between the vector and the cluster center. Then the residual from each cluster is L2 normalized. In this project, it has been also applied the proposed ghost wheel overlap layer, where some of the clusters are not included in the final concatenation and so do not contribute to the final representation. Through this method, the quality of the data is improved since it is reducing the contribution of the noisy and undesirable sections of the speech segments and downweighting their contributions to the final fixed dimensional vector. So this is all about this module, and now we're going to talk about the second core module of this project.
The UIS-RNN network is a fully supervised framework, and it will be used to perform the final diarization tasks. It is formed by three main stages. First, it models how likely a speaker change will happen. Next, if the speaker has changed, the network has to determine if it is a previous speaker or a new one. A person who leads, for example, a conversation will be more likely to speak again, and also a person that often interrupts others. Each situation, a meeting, a call, or a scene has different probabilities for a new person to join as well. Finally, we must estimate the probability of the options to generate the sequence. At a certain moment in the sequence, we can have K or a certain number of RNN instances, each one corresponding to one speaker. So we will have a total of K plus 1 possibilities in the next instant. It can be either a new speaker that will generate another RNN instance or a previous one that will update the one that already exists. The network was trained reaching a stable performance with around 700 iterations. To test the model, we used different audio files with different scenes. As a result, we obtain a timeline that represents which speaker is active at each time frame. We can now see one example. If the sound cannot be listened in the presentation, we apologize. In our report, we have written a link to the different results that have been obtained.
的一辆破吉布满山沟里面乱钻，四处骂人督战。
你们县上就只有一辆吉普车？
太穷了，就这一辆吉普车，还绑在他李大刚的屁股上。我们都是骑自行车。
他李大刚知不知道党的组织原则呀？谁是一把手啊？
据汉东的同志讲啊，李达康就是这么强势。他做县长，县长是一把手；他做书记，书记是一把手。
那他都要当了省长，我还得听他的了。
他这个省长还当得了吗？啊，不管怎么说，他老婆总是出事了嘛。
哎，那是前妻，欧阳靖是他前妻。
哥哥，我最后再说一句啊，能不能帮我个小忙？
说。
把那陈清泉放了，别再追究了。
这陈清泉跟你有商务往来啊？
我不认这人，他是高小琴的人。
那你管这么宽干嘛呀？啊，真以天下为己任了？
以天下为己任，那是你们的事儿。我就是一商人，在商言商。你们在这个山水庄园抓走人了，让我赵某人很没面子。所以我求求你，能不能把人放了？
这事儿你还真说晚了，市常委已经开过会了，决定了。
Different things can be pointed out. First, the dataset have been trained with audios that do not represent all the different aspects of a conversation, such as background noise or different volume. Because of that, it makes some mistakes. For example, when the background music is played, creating a new speaker for that. When no sound is present, the network will return that no speaker is active. But in this case, when no speaker is active, we still have a music. So because of that, it still creates another speaker for that music. In order to compute the diarization error rate, the ground truth timestamps were needed. As we did not have the original ones, we tried to make our own ground truth. However, to do it accurately with the Chinese language is not easy, and we could have made some mistakes. As a summary, we successfully performed a complete diarization process. This DER corresponds to the example shown in the previous slide. As it can be noticed, it is not a great value. Besides the constraints already mentioned, it cannot be ignored the additional limitation that the nature of supervised problem by definition provide. Some future guidelines would be to train and test other datasets with more realistic characteristics. Datasets in where the speaker could be overlapped or where the speakers were present altogether and not artificially merged, as we have done for our training. So this is all, and thank you for listening to us.